Hello everyone. This video is about three-phase voltage source inverter with delta connected load in 120-degree conduction mode. The circuit of the three-phase inverter is shown here, which consists of 6 switches with 6 diodes connected in anti-parallel. The diodes will play a role only if the load is RL, RC or RLC load. Since the load is R, the role of diode will not be there. The switches are numbered in the order in which they are triggered, which means S1 is triggered initially, S2 is triggered after 60-degree interval, and then S3, and then S4, S5, and S6. In 120-degree conduction mode, there will be 2 devices in conduction at any point of time, one from top and another one from the bottom group. And each device will be in conduction for 120-degree duration. There are 6 modes of operation. Mode 1 is from 0 to 60 degree, during which S1 and S6 are in conduction. In mode 2, S1 and S2 will be in conduction. In mode 3, S2 and S3 will be in conduction, and it exists from 120 to 180 degree. In mode 4, S3 and S4 will be in conduction, and in mode 5, S4 and 5 will be in conduction, and in mode 6, S5 and S6 will be in conduction. This is mode 1, during which S6 and S1 are in the on condition. The load it is connected to the source through S1 and S6. The A terminal of the load is connected to the plus of Vs through S1. B terminal is connected through S6 to minus of Vs, and C terminal is kept open. So we can see that this R and this R connected between, that is B connected between this R and this R will be in series connected between B and A. So we can write that your A terminal is connected to plus of Vs and B terminal is connected to minus of Vs. So we can write VAB equal to plus Vs. And since BC and CA, they are sharing the voltage Vs, and since B is connected to the minus of Vs, we can write VBC is equal to minus Vs by 2, and A is connected to plus of Vs and C is again connected to the minus of Vs through this R. We can also write VCA is equal to minus Vs by 2, which means the voltage between B and A terminal, it is minus Vs. VA is minus Vs, which is being shared by these two resistors. So VBC is equal to minus Vs and VCA is equal to VBC is equal to minus Vs by 2 and VCA is equal to minus Vs by 2. In mode 2, S1 and S2 are in the on condition. A terminal is connected to plus of Vs through S1, and C terminal is connected to minus of Vs through S2. And here VAC will be equal to plus Vs. So VCA, we can write it as minus Vs, and VAB is plus Vs by 2 and VBC is plus Vs by 2. This is mode 3, during which S2 and S3 are in the on condition. B is connected to plus of Vs through S3. C is connected to minus of Vs through S2, and A terminal is kept open. So we can write VBC is equal to plus Vs, and VBC, that is VBC is again shared by these two resistors equally. So we can write VAB equal to minus Vs by 2, since B is connected to plus terminal and A terminal is connected through this R2 minus Vs. So we can write VAB equal to minus Vs by 2, and VCA is equal to minus Vs by 2. This is mode 4, during which S3 and S4 are in the on condition. A terminal is connected to minus of Vs through S4. B terminal is connected to plus of Vs through S3. So we can write VAB equal to minus Vs, and this VA is equal to plus Vs. This is being shared by these two resistors equally. So we can write VBC is equal to plus Vs by 2 and VCA is equal to plus Vs by 2. And this is mode 5, during which S4 and S5 are in the on condition. A terminal is connected to minus of Vs through S4. C terminal is connected to plus of Vs through S5. So we can write VAC is equal to plus we can write VAC is equal to minus Vs, or we can write VCA is equal to plus Vs, and this VAC, that is minus Vs, is being shared by these two resistors. So we can write VAB equal to minus Vs by 2 and VPC is equal to minus Vs by 2. And this is mode 6, during which S5 and S6 are in the on condition. B terminal is connected to minus Vs through S6. C is connected to plus Vs through S5, and A terminal is kept open. So this voltage VPC, we can write it as minus Vs. VPC can be written as minus Vs because B is connected to minus of Vs and C is connected to plus of Vs. And this minus Vs, VPC is equal to minus Vs, or we can write VCB equal to plus Vs. This VCB is shared equally by these two resistors. So we can write VCA is equal to plus Vs by 2 and VAB equal to plus Vs by 2. So we have obtained the voltages of VAB, VPC and VCA for the 6 modes of operation. And so we can draw all the voltages VAB, VBC and VCA for the 6 modes. This waveform shows the waveform of VAB, VBC and VCA drawn for 2 full cycles. So for mode 1, VAB equal to plus Vs. At the same time, VBC is equal to minus Vs by 2 and VCA is equal to minus Vs by 2. And for mode 2, VAB is plus Vs by 2, VPC is equal to plus Vs by 2, and VCA is equal to minus Vs. For mode 3, VAB equal to minus Vs by 2, VPC is equal to plus Vs, and VCA is equal to minus Vs by 2. For mode 4, VAB equal to minus Vs, VPC is equal to plus Vs by 2, and VCA is also equal to plus Vs by 2. And for mode 5, VAB is equal to minus Vs by 2, VPC is equal to minus Vs by 2, and VCA is equal to plus Vs. For mode 6, VAB equal to plus Vs by 2, VBC is equal to minus Vs, and VCA is equal to plus Vs by 2. The next cycle again, it is repeating. So we have drawn the waveforms of VAB, VBC and VCA for 2 cycles. So we have seen the 3-phase voltage source inverter in 120-degree conduction mode for delta connected load. And we have also drawn the waveforms of the VAB and VBC and VCA for the 6 modes of operation. Thank you.